So we're on page 63, part of topic 13, and we're going to look at examples on factoring. First thing we're going to do is look at perfect square trinomials. Then look at the difference of squares, see how they're factors, how they're factored, difference and sum of cubes. Here's the difference and here's the sum. These are cubes right here. We're going to discuss that. Greatest common factoring as a first step. And lastly, how we determine if trinomials have integers as factors. So let's go to the first problem. And here we see we're going to talk about perfect square trinomials. You take this one first here, and I've rewritten it here. X squared plus 2x plus 1 equals x plus 1 all squared. So this trinomial is really this. And what this means is that I multiply x plus 1 times x plus 1. And when I do that, the first times the first gives me x squared. The inner is plus x. 1 times x is x. And the outer is also x. 1 times x is x. So if we add the inner and the outer, we get 2x. And the last times the last gives me plus 1. So a perfect square means that the two factors are identical. So here, these two factors are identical. The first term of the trinomial is a perfect square. This is 1x squared. Okay. The last term is also a perfect square. 1 squared gives you 1. So that's this one right here. The last square is a perfect square. And the middle term is twice the outer or twice the inner term using FOIL on the factors. So the first term is a perfect square, the last term is a perfect square, and this is either twice the inner or the outer. Now, of course, you have to pay attention to the sign. So let's go over here. 4x squared minus 12x plus 9, which is this part over here. I'm just going to redo it, is really 2x minus 3 all squared. So it's a perfect square, which means that I multiply 2x minus 3 by 2x minus 3. Now, if I multiply using FOIL 2x times 2x, I get the 4x squared. The inner is minus 6x. The outer is minus 6x. So minus 6x and minus 6x is minus 12x. And so that's how I get the minus 12x here. And the last term is minus 3 times minus 3 gives me plus 9. So twice the inner or the outer term is minus 12x. So here you can see that you've got a minus here. In this case, this must be a minus and that must be a minus. In this case, everything was positive. This was positive and this was positive. So the sign between the terms is positive. In a perfect square where there's a difference involved right here, the middle term is negative and the last term is positive. Now here, supposing we were asked to factor 81x squared minus 126x plus 49 squared. So we ask ourselves, is this a perfect square? Yeah. 9x times 9x gives us 81x squared. 49y squared is a perfect square if we use 7y and 7y. Now the only way we're going to get minus 126 is, you can see here that the inner term is minus 7y times 9xy, which is minus 63xy. So twice that is minus 26xy. and there should be, let me just correct that here. There is a slight error here. This should be y. Okay, now we're okay. So this term right here should be xy. So let's go over this again. 9x times 9x gives us 81x squared. Minus 7y times minus 7y gives us plus 49y squared. And minus 7y times 9x gives us minus 63xy, which if we multiply by 2 gives us minus 126xy, which is this middle term here. Now, the difference of squares is interesting because if you look at it, one way you can recognize it is that there's only two terms here. The first is a perfect square. The last is a perfect square, but there's no middle term. You take the case of x squared minus 4, then you have x plus 2 times x minus 2. So what happens is the inner term, which is plus 2x, cancels with the outer term, which is minus 2x. So they sum to 0. And this always happens if, first of all, this term, or what's in this bracket, is exactly what's in this bracket, except the signs are different. When that happens, we get no middle term. We have a first term and we have a last term, but the plus 2x here, the inner and the outer cancel, so to sum to 0. Let's take a look at 64x squared y to the 4th minus 121y to the 10th. First of all, this is a perfect square. This is a perfect square. So if I multiply xy squared by xy squared, I get xy to the 4th. And of course, 8 times 8 gives me 64. So 8xy squared times 8xy squared gives me 64x squared y to the 4th. Now, 121 is a perfect square, so I can multiply plus 11y to the 5th by minus 11y to the 5th, and I'll get minus 121y to the 10th. Now, the inner term is plus 88, because 8 times 11 is 88, x y to the 7th, because I add the y2 and the 5, I get y7, and I get that, the powers I add. And the outer term is minus 11y to the 5th times plus 8xy squared, and that gives me minus 88xy to the 7th. So the inner term and the outer term sum to 0. Now, just to go back one page, you will see over here that there is a middle term. And the sign here is identical. Over here, when we did this one, there is a middle term, and the signs between the two are identical. Now we go to the case of the perfect squares, where the signs are different, but the factors are the same. So what happens in this case, as I've said before, is the inner and the outer terms sum to 0. The first term is a perfect square. The last term is a perfect square. Now, the sum and difference of cubes. Let's just go back and review from page 61. We saw that x cubed minus y cubed was x minus y. The factors are x minus y. In other words, we just take the x minus the y and we put that here without the cube. Sign is the same here. Now I square this first term here, I get x squared. I multiply x times y and change the sign, and I get plus xy. And then the last term is squared, and I get plus y squared. So this sign is the same as this one, and this one is opposite to that one. Now if I want to do the same thing with x cubed plus y cubed, I get x plus y because of the plus here. First term is x squared. Now because this is a plus, this becomes a minus, and I multiply this times this and I get minus xy plus the last term squared. Now when you actually come to take this, when you take what I put in there, red elliptical here, and I multiply it out, and I multiply x times this term, I get this. So I multiply x times the first term using the distributive rule, minus y times this, which is this here. When I work it out, I get x times x squared gives me x cubed. X times plus xy gives me plus x squared y. X times y squared gives me plus xy squared. So that's the green term. Now I multiply minus y times x squared y, and I get minus x squared y. So minus y times x squared gives me minus x squared y. Then minus y times plus xy gives me minus xy squared. And minus y times plus y squared gives me minus y cubed. Now what happens is this red term cancels with that one because one is plus and one is minus. Same thing with the green term here. This plus xy squared cancels with that xy squared, and I'm left with x cubed minus y cubed. So this is just showing me that this is the case. Now if I apply basically what I've learned here in the difference of cubes, I write x cubed minus 8 equals x cubed minus 2 cubed. Cube means the power is 3, so 2 cubed gives me 8. So now I put the x here, I put the minus here, and I put the 2 here. Now I multiply these two together. Get 2x and change the sign, plus 2x, square minus 2, and I get plus 4. This is this, and this is identical to this, except that 2 squared has been written as 4. All right, do the same with a sum of cubes. 8x cubed plus 27 is really 2x cubed because 2x times 2x times 2x gives me 8x cubed. What this means is I take the 2x and multiply it by itself 3 times, and I get 8x cubed. I multiply 3 to the power 3 means 3 times 3 times 3, which is 3 cubed. That gives me 27. 3 squared is 9, 3 cubed is 27. Now I take this, put this here, plus goes here, and the 3 goes here. Now I square this term, or I square this term, get 2x squared, multiply 3 times 2x, but change the sign, and then plus 3 over here becomes plus 3 squared. So 2x squared becomes 4x squared, minus 2x times 3 becomes minus 6x, and 3 squared becomes 9. Now if I multiply this term by this term, I should get that. How do I do that? I multiply the 2x times everything in the second bracket. I multiply plus 3 times everything in the second bracket, and I cancel like terms, and I will get 8x cubed plus 27. Same thing here. I multiply x times x squared plus 2x plus 4, and then minus 2 times x squared plus 2x plus 4. I'm going to get x cubed minus 8. So here we have a problem where we have 27x to the 6 minus 125y to the 9th. Now 27 is 3 cubed. X to the 6th is x squared cubed, because 3 times 2 give me 6. Instead of 125, I write 5 cubed. Instead of y to the 9th, I write y cubed cubed. 3 times 3 is 9. So now I put the 3 here, put the x squared here, minus 5 times this term here, y cubed. I mean, we're essentially doing something analogous to what has been done up here. Now, when I square this first term, I get 9x to the 4th. I multiply minus 5y cubed times 3x squared, change the sign, I get plus 15x squared y cubed. And I square this last term, I get plus 25y to the 6th. So these are the factors of this. Now, if I were to take the 3x squared, multiply it by everything here, and then subtract 5y cubed and multiply it by everything here, it would simplify to this. Just as we did over here with this problem. We multiplied the x times everything in this bracket right over here, and we multiplied then minus y times everything in the second bracket using the distributive rule and got that. Now, before we factor, as a very first step, we should see if there's any common terms between the terms that were given to factor. Now, by the way, in this, there's a slight error. This plus should be a minus. If I look at 2x cubed, 14x squared, and 36x, I first of all ask myself, what's the highest integer that goes into 2, 14, and 36? And the highest integer is 2. So the highest integer that goes into each of those coefficients, 2, minus 14, and 36, is 2. Now I ask myself, I have x cubed, x squared, and x. So I always choose the lower power of x in the three terms, and that is x to the 1 or x. In other words, here there's a cube, here there's a squared, here there's a 1. I always choose the lower one, the lowest one of the three. Okay. Now, I combine the 2 and the x, and I get 2x. So I can factor out from these three terms, I can factor out 2x as my first step. So I look for the greatest common factoring before I do anything else, 2x. Okay? Now, 2x times x squared gives me 2x cubed. 2x times minus 7x gives me minus 14x squared. And 2x times minus 18 gives me minus 36x. So, as I said here, this plus should be a minus. And we'll see why in a second. So, when I factor this, I ask myself, now, what are the factors that would give me this? And you can see x minus 9, x plus 2. Why? X times x gives me x squared. My inner is minus 9x, and my outer is plus 2x. So I get minus 7x. And minus 2 times plus 2 gives me minus 18. Now what I can ask myself is, what are the factors of minus 18 that sum to, what are the factors of minus 18 that sum to minus 7? And it has to be minus 9 and plus 2. So there are different ways of doing it. You can see here anyway that what I get is minus 9x plus 2x, inner and outer, combined to give me minus 7x. And so you can see I've done the problem over here. And again, let me repeat, I've rewritten it in the correct form. What we ask ourselves, what are the factors of minus 18 that sum to give us minus 7x? And they have to be minus 9x and the plus 2x inner and outer. So this must be minus 9 plus 2. You'll see that if I had, for example, used 18 or 1, there's no way that I could get 7 minus 7x. Or if I use 6 and 3. If I combine 6 and 3, there's no way I can combine them, add them to give me minus 7x. And you could say, well, what about 9 and plus 2? Well, plus 9 and if we use plus 9 and minus 2. Well, plus 9 and minus 2, when they sum together, would give you plus 7x, not minus 7x. So it has to be minus 9x plus 2 so that you get the right middle term here. Remember, the inner and outer on FOIL always combine to give you the middle term. Whenever you start to factor, first determine there is a GCF. We could have started to do some factoring here, but it would have been much more complicated than if we hadn't taken the 2x out of here as the greatest common factor. So we're going to really do a lot of problems later on. The first thing we're going to ask ourselves before we do anything is find if there is a greatest common factor, which means, in this case, what's the highest number that goes into all these three numbers? And the answer is 2. And if I've got an x cubed and I've got x squared and I've got x to the 1, what's the common factor? Well, it's the lowest one, x to the 1 or x. If we have two the same, we choose that one which is lowest. Okay, if this was also x squared, we still factor out the x squared because it would be the lowest value of x. Now, the last piece on page 63 that we're going to discuss is how do we determine if a trinomial is factorable? So here we have 2x squared plus 3x minus 9. And for this, a is deemed to be the coefficient of x squared, b is the coefficient of x, and c is the number minus 1. Oh, I see there's a mistake here, and this should be, minus 1. So we'll do that. Just take that out of there. Okay, so in this case, a is 2, coefficient of x squared, b is plus 3, and c is minus 1. And then we work out b squared minus 4ac, which becomes b squared is 3 squared minus 4a, a is 2, and c is minus 1. So when we 9 plus, this becomes plus 8. It becomes 9 plus 8 is 17. It's not factorable with integers using integers, since 17 is not a perfect square. Now, I'll just go back to page 61 and review for you what the theory was here. ax squared plus bx plus c can be factored over integers, which means that you can only have integer solution if b squared minus 4ac equals 0, 1, 4, 9, 16. Now, 1 is 1 squared. 4 is 2 squared. 9 is 3 squared. 16 is 4 squared. 25 is 5 squared. So, and also if b squared minus 4a equals c, it's a perfect squared trinomial. So in this case, if we look at the answer, we look at 17 that we get for this problem right here. You can see that we can't factor this using integers because it isn't 17 is none of these numbers. The next number would be 25, so it doesn't fit. So that completes our discussion of page 63, excuse me. That just completes our discussion of page 63.